So here in the naive Bayes, it is one sort of probabilistic approach rather than an algorithm. I could say that this naive Bayes is completely based upon a probabilistic approach, a very basic probabilistic approach that we can always go ahead. The main probability that this will rely on the Gaussian distribution. Okay, so the probability that Gaussian probability distribution will be relying. Okay, this particular naive Bayes is completely based upon a formula, probabilistic formula. Okay, so let us try the cross validation part and the splitting of the data as usual, like whatever that we have done for the same social network ads. Okay, which is the one we are using for the earlier examples also. Now, I'm trying to fit the naive Bayes to the training set. So in order to fit this one, I always have to understand that I am required to use something called naive Bayes from the scientific learn. The scientific learn dot naive Bayes import Gaussian NB represents Gaussian function. So here the classifier is equal to Gaussian NB function and classifier dot fit. You have to provide the valid x and y values associated with this one. Okay. Now, I haven't given any sort of priority. Rather, I will show you this one, Gaussian NB. sklearn, naive Bayes. So in order to make this algorithm to work, here is the one which you need to use, which is a Gaussian NB. You will find the two different algorithms in this. One is the priors is equal to none and variable smoothing. Okay, is equal to a value which is 1 into e power minus 9. Okay, so here generally we will use the parameters. One is a priors. This represents where the data, whatever that we are trying to choose, okay, which is having a certain type of array type of data, whatever it is, the prior probabilities of the classes are none. We are representing that prior probabilities of the classes are none. Okay, if the priors are there, if specified, the priors are not adjusted according to the data. That's why we have just given priors is equal to none, which is already there as per the documentation of the scientific learned function, which is Gaussian NB. Okay, and the next one is variable smoothing. Okay, variable smoothing, where underscore smoothing is the main argument that we will be using it, and by default it will have the value which is 1 into e power minus 9, the portion of the largest variance of all the features that is added to the variances. Okay, so anyhow, now let me just go ahead. By default, that's why it has shown you, it has taken the Gaussian NB priors is equal to none. Now let me execute this confusion matrix. Okay. So from the confusion matrix, can you please identify the accuracy of this model? What is the accuracy of this model, guys? 65 plus 25, how much is going to be? 90. 90 divided by 100, which is going to be 90%, which is really a good classifier for this kind of data set that I've used. Okay, so now by taking a look at this particular result set, let me just make a visualization of this one. So this is how the navy Bayes have taken its own curve. As I told you, this is a probabilistic approach, and this probabilistic approach will always have something just like a probabilistic curves within the way that they are segregating or segmenting the data, doing the segmentation of the data. Okay, so this is about the test results. Okay, any questions so far, guys? Are we good? Are we good with the navy Bayes? I will also show you what exactly the navy Bayes formula runs with. So this is the formula generally navy Bayes will be used in order to implement. See, P of C or X refers to P of X into P of C divided by P of X. Means here, this is the probability which is related to the posterior probability. And you can make it chunk, you can make it as a chunk like P of C of X is equal to P of X1 or C into P of X2 or C into something like this completely into P of C. So the P of C refers to the class prior probability, and the P of X or C refers to the likelihood of the element, and here it is the predictor prior probability. So this is the general Bayes rule, okay, which is a probabilistic rule that we would be following in order to implement the data classification using this navy Bayes. Any questions so far, guys? Let me try using the same way. Okay, we have discussed yesterday about the random forest. We can use the same data set, and we can try using the random forest classification, how exactly that it will go again. See, as I told you, for the random forest and a couple of other more classification, it is required some sort of scaling actually. Okay, so even if you can understand, navy Bayes have implemented a scaling, and decision tree have implemented a scaling. Hence, we are also required to implement the scaling here in the random forest classification model. So here also the entire scaling methodology, everything is same. And the criterion I have clearly mentioned as an entropy criteria, okay, when I'm taking it as a random forest. And also the random underscore state is equal to 0. And how many estimators that I want something? 10. Let us try understanding this random forest classifier from the ensemble models. Generally, these models are called as ensemble models. We will generally call these things as ensemble models. Ensemble models in the scientific learn. So, in order to import the random forest classifier, we need to import something from the scientific learn, okay, and we need to give it something like ensemble, okay. Let us try using these things. Scikit-learn. So here we have, so this is a random forest which is taking a lot of arguments inside, which I just wanted to say this the scientific learn, whatever the random forest classifier is existing, okay, there will be lot of estimators. If you, I mean, based upon your data that you want, okay, how it is required to be done. See, you can clearly understand the default estimators are by default 10 different estimators, okay. So these are none other than, yesterday we have observed and clearly understood there are a number of decision trees needs to be extended, okay. When we have the same sort of decision trees needs to be taken as a sample, and we will be executing the samples, different types of samples taken out of from a random forest, okay. What happens, okay, you will get a lot of samples. Based upon that one, you can always try extending the existing tree, okay. When you are trying to use the n underscore estimators, they are none other than the number of trees that you are trying to keep it in the forest, Okay. So here, why are we using the random forest? We need to understand that part. So guys, we understood based upon the decision tree implementation, we have some sort of understanding. By implementing the decision tree, we are unable to extend further at one particular point of child nodes. So in order to implement the further extension, or by taking a maximum allowable classifiers within the decision tree or the different nodes to be existing. Okay, this random forest can be considered as a number of the best estimator in order to make further more classifiers within the decision tree, and which will make the subsamples of the data set, which could be used in order to do the best predictive accuracy. Okay, where it will control the overfitting also. So now let us try understanding this part. Let me show you. If you want to go ahead with the criterion, you can go for the criterion as Gini, but in our case that we went ahead as criterion as entropy model. Okay, and also there, after all, there are different parameters. I just want to show you that one more thing is that I have selected is random underscore state. Okay, by default it is a 0, and rest of the things by defaulted with the a regular none, and default boolean value will be true, and default boolean values would be false based upon the out of bag scores or the bootstrap kind of arguments that we are going to select when building the trees. Okay, now let us try this thing and let me execute. Okay, file is not found. Let me try to change this part here. So prediction executed, and let me just go ahead with the confusion matrix here. Here you should see that the confusion matrix has given you something related, which is around 92 percentage, which is the best one where you have got with the random forest. Okay, so 92 divided by 100, which is going to the 92 percentage of this. So let us try looking after the visualizations, how well we went ahead with this one. So you could observe it's more or less something just like a decision tree. Okay, how it is showing you the results. Also, I just want to show you one example. Okay, I think actually I thought of showing you one more method actually. Okay, I will check it out one more time and I will try to show you. Okay. Meanwhile, let me go ahead with the clustering examples. Okay. See, we have in clustering, we do have two different types of clusters. One is k-means cluster, and another one is hierarchical clustering. Okay, k-means clustering and hierarchical clustering. Okay, so now we have something called mal underscore customers, where we are going to deal with a kind of data related to the customers and their spending in a one particular shopping mall. So the shopping mall has given a spending score for each and every individual of their customers, and they have come up with some sort of data based upon their age, annual income, and based upon that they have understand to implement some spending score. Okay, understand? So based upon this one, let us try understanding exactly how the clustering works. But before understanding about that one, let me explain a clear brief about this clustering, how exactly that looks like. Okay, so guys, in the clustering part, what exactly it happens, So let me just show you the, whenever we have something, the data which is representing like no, actually, I just want to create couple of individual bubbles actually. So hence I'm trying to pick this one. Mostly, this kind of clustering will be implemented in the medical fields also. So guys, what happens? You can see some data representation in the pictorial format. Okay, see, we have seen some data, you know, which is represented in the pictorial format over here. Whatever that you can see by understanding this one, see all this kind of stuff like will definitely based upon the distance based measures actually. So when something couple of data measures have been very much close together, what it will happen whenever I see something like this. Okay, this is followed by the next immediate thing. What is going to happen is it will go ahead and club together the data. Okay, it will just observe the very nearby data bubble and it will merge it together and it will show a little bit of group data. Okay, and it will be clustering together by accepting all this data. Okay, together, and it will become a one particular entity during that time. Hence you can do the clustering of the data in this scenario by clubbing up together the data bubbles which are close to each other. So based upon the way that however that you wanted to club the data, there it derives with the k-means clustering and hierarchical clustering. There are two different ways of doing the clustering. Okay, here we do have the different approaches, which is a k-means clustering, and another one is hierarchical clustering. Okay, just give me a moment, guys. Okay, fine. Now let us see an example on this one. You can see the mall underscore customers, which is located over here. So for both of these two things, I'm going to use the mall underscore customers. So where I just wanted to make the okay, control C. So I'm going to use the forward slash stuff. See, importing the libraries, I'm going to work with this k-means clustering and then data set. Okay, done. Let me just clear off this part. Now, see, no scaling is required for this sort of clustering, hence I have just disabled or commented there. Okay, now I'm trying to use something called the k-means from the cluster. Okay, so scientific learned cluster is a required thing where you can import this k-means function. So if you can take a look at this part, you can clearly understand scikit-learn. Okay, so this k-means clustering will consist, several individual arguments that you can pass through, out of which that we can clearly see the n underscore clusters is the main stuff that you can see that by default it is having the 8 clusters, either which that here we have anyhow preferred 5. Okay, in the k-means clustering we have tried picking up for the 5 clusters, and anyhow like I'm trying to show this is going to be the elbow method, okay, which is a method that we are trying to use. Okay, elbow method. Okay, so the elbow method represents the graphical representation of the number of clusters and how they have been represented within a line, and here I'm trying to fit the same thing over here for the prediction purposes. And now let me try visualizing the entire stuff. So this is how the clustering can be done, so that you can clearly observe the different 5 different clusters and the centroid for each and every cluster. There will be a one centroid for each and every cluster over there here. Okay, guys, understand this one? All of you understand this one? Sunil, is it? Okay. See, try, going through the video. Otherwise, if you have any questions, please mention me in the tomorrow session itself. Okay. I will just clear your questions based upon that. So let me just go ahead with the hierarchical clustering. In the hierarchical clustering too, the same sort of, scaling is not required over here, but you can clearly understand here within the cluster whatever that I'm trying to use. And also you can clearly observe the what kind of, I'm not using the scikit-learn over here. And also you could take a look at this one here. I have used something called a scikit-learn, whereas I have used the scipy over here in order to access the hierarchical model, where I'm calling this as a dendrogram. So generally this dendrogram is the one which is used in the hierarchical clustering purposes. And let me just show you, this is how it looks like based upon the data that we do have, how the customer spending rate, it was understood from based upon the data spending score, it was understood. Okay, you can always segregate the customers into different segments. Okay, based upon the Euclidean distance. Okay, based upon the Euclidean distance. I told you this entire clustering concept will be relied only on the distance formulas. Okay, the close by each other to be clustered. And if you can even, you can save this image. Let me save this image as a PNG file on the desktop as a hierarchy. You could see this one. Now guys, if you go with this, now let me just try to use the agglomerative clustering, which is coming under the clustering part of the scikit-learn, where I'm trying to implement that one. Whereas the affinity that I'm going, number of clusters is going to be 5, as somehow that I've used for the k-means clustering, and also the same data that I have used. And the affinity I'm using is the Euclidean distance formula. Now, the method which I'm using here is a ward. Okay, ward is a method. Okay, now let me try visualizing these clusters. So these are the different types of clusters that we have come up with, and you can clearly observe the way that how it was different with in between the k-means clustering and the hierarchical clustering. Okay, in the k-means clustering, you can identify the centroids, but it will first identify the centroid, and the distance between all the other points towards the centroid will be will be made for each and every cluster actually. Okay, for all the clubbed together data, okay, there will be one centroid, and you can see the 5 different clusters having 5 different centroids. The same way, we don't have the centroids here in the hierarchical clustering, and we have the different data understanding clusters over here. I will still explain you a little bit more about this clustering part. We have to discuss a little bit conceptual related stuff. Okay, I will discuss that one, and along with that one I will be covering tomorrow about the algorithms related to the a priori and eclat. Okay, so they are related to the association rule learning, followed by I will try to make you understand about the reinforcement learning if I find time tomorrow. Okay, so based upon that we can carry forward. Based upon that one, we will be most probably tomorrow is Friday, right? And on Saturday we can discuss about natural language processing. Okay, natural language processing, and we'll let you know if we can have the natural language processing associated with the image recognition using the neural networks. Okay, we'll talk about it. Okay, okay, fine guys, we'll meet again tomorrow and we will discuss a couple of more algorithms or the machine learning programs. See you.